So a continuation of example 7, especially when it comes to the concept of a p-value. I thought I would do this separately so that it's clear and it's not messy. So just as a recap, I'd like to revisit what we've done before. We determined that we have a critical value of negative 1.761. We calculated a test statistic of negative 4.97, and we said that because of this, we reject HO. So now if we wanted to calculate the p-value for this, we have to be very careful because it's going to involve some estimation. So follow these steps very carefully. First things first, go back to your t-table. Locate the critical value that you located before. So in this particular case, it's negative 1.761, which is right here. Actually, I'm going to make it a little bit bigger here. And these are all positives, so make your test statistic also positive. Again, it doesn't matter because they're symmetrical. Whichever way you do it, it's going to come out to be the same. But this table is positive, so therefore everything needs to be positive. So I'll remind you that our test statistic, t-stat, if we just take the positive version of it, it's going to be negative 4.97. And so once you are at your critical value, ask yourself, where is my test statistic? Is it greater than or less than this value? Of course, 4.97 is greater than 1.761. And so what you do is you move to the right. You get to another critical value. Ask yourself the same question again. Is my test statistic bigger than this or less than this? In this case, it's bigger. And you keep doing this until you get to the end. In this particular case, you get to the end because your value is much, much more to the right. And so what we can conclude now is that because this number here has a p-value of 0.005 or 0.5%, this guy here has to have a p-value that is even smaller than that. And so just to illustrate, this entire region here is going to be 0.005 because of this. And so our p-value will be even smaller because our test statistic, so for example here, this one is going to be 2.97, which is this value right here. So once we have that value, we know that everything to the right of it is going to be 0.5%. Ours is actually even further to the right. It is 4.97. So you can imagine how small this remaining area is. And so in this particular case, the p-value is approximately equal to 0. And so since p is less than alpha, 0% is less than your initial 5%, we reject HO. Let's do another example really quickly, a small assumption here or a small modification. Let's say your t-value is actually, I don't know, let's call it 2. And so one more time, if this is your t and that is equal to 1.761, 2 would be here, you know that it's a reject. So it's the same exact answer, except I chose 2 because it's a much smaller number than 4. Effectively, the test statistic before was close to even 5. And so let's do the same procedure I just showed you again. You go to your initial critical value and you ask yourself, well, is my test statistic bigger or less than that? Clearly it's bigger, you move to the right. You get to this number. You ask yourself, is my test statistic bigger or less than this number? Well, in this particular case, your number 2 is somewhere here. It is less than. And so now you know that your p-value for this test statistic is somewhere between 5 and 2.5%. And so you can write it as follows. This column, just to kind of remind you, this column, all of these numbers here have 0.5% to the right of them. All of these numbers here have 0.5% to the right of them. And so here we can say that our t is less than, take this number here, 2.145. And it is greater than 1.761. And pay attention to this part, the signs flip. So the p-value for this particular t, so the p for this t has a p-value that is greater than 2.5%. At the same time, it has a p-value that is less than 5%, right? Because it is between both of these values. So it's here, the p-value is greater than 2.5. Let me clean this up here for everyone. So we found 2 to be here, and p-values work in the opposite direction as your standard normal numbers. So the p-value for us is somewhere here. The p-value for this 2 is in the middle between 2.5 and 5. And so the decision rule is still good because let's rewrite it here just a little bit to show you how this works. So it is still less than 5%. And so t is less than alpha, or excuse me, p is less than alpha. And so we reject HO. So this has been an example of how to use p-values when you're dealing with the t-table. You can never get an exact answer like the z values allowed us to do. With a t-table, you have to use an approximation similar to what I just showed you.